So in the previous classes, we have studied what do you mean by heat, what do you mean by work, how the energy in the form of heat and work are crossing the boundaries of a closed system, and how heat and work are represented. In the previous class, we have studied, and also we have studied what are the similarities between heat and work. So there we have studied both heat and work. They are dependent on the path followed, not on the end states. So now let us prove that work is called a path function. So here we have considered here three processes. One is process A, that means the system is moving from state 1 to state 2 by following path A. I will call it as a process 1, process A. And another system, it is reaching from state 1 to state 2 by following path B. I will call this as the process B. And another system, it is reaching from state 1 to state 2 by following path C. We will call it as the process C. So now you can see here we are having three paths: path A, path B, and path C. That is, the system is reaching from state 1 to state 2 along these three paths. Since the area under each curve represents the work done for each process. Since the area under each curve, so this is one curve, so the area under this curve, it represents the work done during process A. And the area under this curve, this entire thing, this area under each curve, it represents the work done for process B. And the area under this curve, it represents the work done during the process C. So roughly I have written here, for this area, work done during process A is 8 kilojoules. Similarly, the work done during this process B is 10 kilojoules. Similarly, the work done during this process is 12 kilojoules, because the area under each curve, it represents the work done for each process, and the area under each curves are different. They are not same here. The area under each curves are not same here. So we can easily tell that the amount of work done in each process, it does not depends on the end states of the process, but it depends on the path followed during the process from state 1 to state 2. For this reason, work is called as the path function. Because see here, so this area is different. If the system is reaching from this state 1 to state 2 through this path, here the area is different. That means definitely the work done is different. If the system is reaching from state 1 to state 2, the area under this curve is different. Definitely the work done will be different. Here also the work done will be different. So easily we can tell that the amount of work done in each process, it does not depends on the end states of the process, but it depends on the path followed during the process from state 1 to state 2. For this reason, work is called a path function. And these path functions have inexact differentials. Because if I am following this path, work done is different here. If I am following this path, work done is different. For that purpose, the path functions always have inexact differentials, and they are designated by the symbol delta W or delta Q instead of dW or dQ. Instead of dW or dQ. See here, you can see here, if the work done is different for different processes, then definitely the heat transfer will be different only, because as the area increases, the heat transfer also increases. See, this area is different, and definitely the heat transfer will be different here. And for this area, again heat transfer will be different here. For this much area, the heat transfer will be different here. For that purpose, we are calling Both heat and work are path function. They are not dependent on the end states of the process. They are mainly dependent on the path which is followed during the process. Next, now we'll prove that